Hi everyone, thank you for joining SLR's webinar today on climate risk assessment and adaptation planning. Your presenter today is going to be Sam Gill, but before we get started, I'm just going to run through some quick housekeeping. So to ensure everyone can hear the presentation and to minimise any background noise, everyone will be muted, but we of course welcome contributions and questions. So please make sure to use the question box on the screen and we can pick up some of your questions at the end. So I'll pass over to you, Sam.
Great. Thanks very much. Good afternoon, everybody, or whatever time it is if you're watching this a little bit later. So what I'm going to do today is essentially run through a webinar talking a little bit about the climate context and essentially what we need to be thinking about when it comes to climate change risk assessments and adaptation plans. And this is following on from a webinar that we did a week ago, which was looking at the latest EU regulations, in particular the EU Taxonomy. So it's somewhat part two, but also a standalone webinar. What I wanted to do, just perhaps before, before diving in a bit deeper, is do a poll with you, just to sort of see where you're at in terms of thinking around adaptation plans. So let's just put that on the screen, and if you want to interact with it, then feel free to do so. So where are you in your journey towards performing a climate change risk assessment and adaptation plan? Give people another moment or so. Okay, so it's looking like some people have already started. Some people thinking about this, something they need to be worrying about in the next 12 months, a few as well, looking 24 months out, and then some also thinking whether or not they actually need to do that. So a bit of a mix. Great. Well, let's perhaps end that, and then we can come back to that a bit later. So yeah, it sounds like people are at different stages in their journey, which makes sense. And what part of what we'll cover today is that piece around the extent to which you are actually required to do this or not from a regulatory point of view. But what I thought would be useful before we talk about that is really just to sort of recap where we're at in terms of climate change. Now, you might have seen, came out a few days ago, the 2024 State of the Climate Report. So we've got essentially three, it's quite a good report in that it provides a few different graphics. So we've got on the left, world surface air temperature. And then we've got in the middle, ocean sea surface temperature anomaly. And then on the right, global sea ice extent. And essentially what we've got is the average over the last sort of slightly different time ranges. Last 150 years for sea surface air temperature, a little bit more recent, 25 years or so for the ocean, and then again 25 years for the sea ice extent. And essentially what we've got is those averages over that period of time, and then we've got what we've seen in the last couple of years. And essentially what we're seeing is certainly more extreme ends of the spectrum. So there's some debate in the community as to whether or not things might be accelerating or getting worse. And obviously you need lots of data to draw these definitive conclusions, but you can allow you to draw your own from what you're seeing in front of you. But essentially, we are starting to see things change quite significantly. And where there's an article at the beginning of the year from the Financial Times, which was essentially looking at the 12-month average from February 2023 to January 2024, which essentially was showing that during that 12-month period, the global average temperature was indeed above 1.5 degrees, which, as you probably aware, has been held up as this target beyond which we should not go when it comes to the global average temperature. In terms of trying to not trigger more climate impacts. So we're certainly seeing arguably this idea of keeping temperatures below 1.5 degrees. Obviously the sooner we can bring things back down, the better. But we've already breached that limit, and there are various infographics out there that sort of show the comparison between, for example, the amount of climate impacts at 1.5 degrees versus, say, 2 degrees. Obviously, it's getting worse all the time for every incremental amount of extra warming. The other point then to make really is that, so this is from the IPCC report back in 2021, and essentially what we've got here is the what different levels of warming mean in terms of the likelihood and also the intensity of extreme weather events occurring. So we've got essentially extreme temperatures on the left. In the middle, we've got heavy precipitation, and then on the right, we've got drought. And essentially what this chart is showing, so we've got the sort of the present, then we've got 1.5 degrees, 2 degrees, 4 degrees, and it's showing essentially the magnitude of that impact, so the extent to which it might be hotter, and then also the likelihood. So you might be able to sort of see that in there represented by these little dots. And essentially the key point here is that as temperature warms, we can expect the likelihood and the intensity of extreme weather events to increase. And that's pretty much been consistently the message for quite a long time. Sometimes people talk about, well, can you attribute a specific, say, hurricane to climate change? And there has actually been quite a lot of attribution analysis now done in the academic community to actually do that. But I mean, generally, without getting overly focused on a specific incident, it's the general trend that is the point that is what you need to pay attention to. In terms of the actual impact of that, so this is two charts. One is looking at the number of disasters over time. So we've got drought, flood, extreme weather, extreme temperature, wildfire, etc. And on the right, we've got the number of $1 billion plus disasters. So that's from 1980 to 2023. And essentially what we can see in both of these charts is the trend increasing over time. And unless we bring temperatures back down, we can certainly expect that to be continuing going into the future. You've probably seen the news last week with the Hurricane Milton in Florida. Initial estimates are saying that might be around $50 billion worth of damage. I imagine they're still assessing that. But really the key point here is that you can expect more physical impacts from extreme weather events because of rising temperature going forward. And therefore that's something that you need to be planning for if you have any assets, really, which most companies, unless you're completely living in the metaverse, you are going to have some physical assets somewhere. And even if you are in the metaverse, you're going to have a data center or whatever it is powering that. So this really is relevant for everybody. You might be familiar with the concept of transition plans, which can often be thought about as just focusing on the sort of how you transition your business to be low carbon. But actually, really, the idea of a transition plan is, on the one hand, how do you decarbonize, and on the other hand, how do you increase climate resilience? So this is essentially a report that came out from the UK's Transition Plan Task Force talking about adaptation. And essentially, really the key point here, so this sort of diagram we've got in the middle, is what we're saying is, if you have a situation where you imagine there's no climate change, your cash flows might be that orange line in the middle. If you then imagine a situation where we do have climate change impacts, which obviously we do, as I've just shown you, then you can expect your cash flow to be impacted negatively going forward because your assets are going to be impacted by these kind of natural disasters. So therefore, if you increase your climate resilience and then you're less affected by these climate impacts, you can expect your cash flow to increase over time. And essentially what we're going to be talking about here is this idea of how do you go about that? And really, it's thinking about screening for climate hazards, performing a climate change risk assessment. Once you've identified those climate change risks, developing a climate adaptation plan. In other words, how do you mitigate those risks? And that actually is a recipe for increasing cash flow over time. Obviously, you might have to invest some money to do a risk assessment or perhaps to build some sort of climate adaptation measure, but ultimately in the long run that makes sense from a cash flow point of view. And hopefully that's relatively straightforward, but sometimes it can be helpful to try and make that case financially to a board or whoever else it might be that's signing off on that. So that's a little bit of the context. What I want to do now is just mention, sort of following on from the webinar I did last week, the regulatory landscape. And so the EU regulatory environment has a few different pieces of legislation, but perhaps most important is the CSRD, which is essentially becoming mandatory for large companies this year and will scale up to cover more and more companies over the next 5 years or so, to the point where it will actually cover 50,000 companies, which is obviously quite a lot. Now, what's particularly interesting about that number, the 50,000 companies, is that they will also then need to report their alignment with the EU taxonomy. And that's essentially tracking at the same time that those companies fall under the purview of the CSRD. So if you are a company covered by the CSRD, you need to explain and disclose your alignment with the EU taxonomy. Now, what's interesting about the EU taxonomy is essentially that it is requiring companies to perform a climate change risk assessment and develop an adaptation plan as part of this demonstration that the company is doing no significant harm when it comes to climate change adaptation. So the key takeaway here, if you're doing CSRD, you need to do EU taxonomy. And if you're doing EU taxonomy, that always includes the requirement to do a climate change risk assessment and adaptation plan. And if you want a little bit more detail on those requirements, there's, as I say, the webinar that we did last week. So just to sort of recap, what does the EU taxonomy talk about? Well, to be fully aligned, you're having to show that you're making a substantial contribution to one of these 6 environmental objectives. And then you're also having to show that you're doing no significant harm against the other objectives, as well as then demonstrating that the company is in line with or meeting the minimum social safeguards, and all of those things, if they are met, enable you to say that you're fully aligned. The making a substantial contribution, the doing no significant harm, that is essentially specific to an activity, whereas minimum social safeguards is undertaking specific. So the key thing here, though, is that when we look at the do no significant harm criteria, there's a few different points: climate change adaptation, sustainable use and protection of water and marine resources, transition to a circular economy, pollution prevention and control, and then protection and restoration of biodiversity and ecosystems. So yeah, quite a few different points, but the climate adaptation piece essentially applies to all activities that are covered under the EU taxonomy. And that's essentially the focus of what we're going to be talking about today, which is these climate risk assessments. So how do we think about this at SLR, and therefore, what is our approach to this challenge? Well, the first thing to say is, what do the reporting requirements ask of you? And really, obviously, there's quite a few different reporting regimes out there: EU taxonomy, CSRD. You've also got things like the equator principles, so often used by institutional investors when allocating capital to new projects. If you're in the UK, there's the Environment Agency. They recently required certain companies that had to get environmental permits to perform a climate risk assessment. You've got the ISO standards, you've got the IFRS S2, and then also, as I just mentioned, there's the Transition Plan Task Force. And essentially, when you look at across all these different things, what they're basically telling you to do is that you need to screen for climate hazards, you need to assess your risks, you also need to incorporate the idea of scenario analysis, and then finally, once you've done all of that and you've got your risks, then you need to develop an adaptation plan. And that essentially is how we are then proposing, or that's how we do this for clients when we help them. We try to follow this best practice. Another point to mention here, so many companies will be covered by, if you're particularly in Europe, CSRD. If you're reporting in the UK, you'll be doing TCFD, which is now rolling up into the IFRS S2 standard. Or if you're a global company, that's most likely what you're going to be doing. And the key point here is that you could actually sort of kill a few birds with one stone in doing this, in that you're ticking multiple boxes when you perform a climate risk assessment. That also feeds into your climate scenario analysis for CSRD, for example. So how do we approach this? Well, essentially we have a three-phased approach, and it somewhat depends on the size and complexity of your business which one we would recommend. So if you have a lot of assets, then we would recommend starting off with essentially doing a heat mapping exercise across your assets to identify which of those locations are most at risk, so that you could then move to this phase 2, which would be an asset specific deep dive. Obviously, if you're a relatively simple business that has, say, 2 key locations, you might just skip to phase 2 and just focus on those key locations that you already know. However, if you're a business with 1,000 different manufacturing sites, then that's probably not really going to be possible, and also it's not really going to be cost effective to be doing a deep dive on every single site. So really the purpose here is to have a way to prioritize which sites to look at. There is increasing pressure to be looking across the supply chain as well when you're thinking about your climate change risks. So CSRD, for example, includes the requirement to do value chain mapping. There's also the CSRD, which is also very much supply chain focused. And so this approach can also be used when you're thinking about suppliers as well. So this phase 2, that's essentially where we would do a more in-depth analysis of a particular site, really trying to understand the specific interaction of climate change hazards with whatever is happening, the processes, the infrastructure at a particular site, and then be able to determine those risks. And then this phase 3 essentially is where we're seeing our clients want to go next, which is, okay, I've identified the relevant sites, I've identified the relevant risks. Now what I want to do is actually start thinking about adaptation, and if there are significant costs involved, then actually being able to sort of do a cost-benefit analysis and understand how much these things are actually going to cost. So that's really that phase 3, starting to think about the modeling around the costs. We're also actually seeing that interest come from investors who are starting to think about their portfolio and their holdings. And sometimes they may have portfolio companies that are more or less mature when it comes to this, but they might even have some companies that are somewhat in denial about the existence of climate change and these risks. So from their point of view, it can be quite important to understand the exposure of their portfolio and also how much investment might be required to adapt to a changing climate. So it's also, particularly if you're in a corporate, interesting to think about how your investors might be thinking about this as well. So that's a sort of overview of our approach. And then what I'll do now is just go into a little bit more detail on how we go about that. So this is an example of what a climate risk heat map looks like. And so on the left-hand side, we can see we've got multiple different sites. We're looking at 3 different time horizons here. So the baseline, essentially present day, 2050, and then out to 2100. That might be a bit further than some clients might be looking at, but this gives you a bit of a sense of the range. And essentially what we're then seeing here is across a range of physical indicators, we're seeing a hazard score from 1 to 10. And so one is good, 10 is bad. And essentially this hazard score is incorporating the concept of likelihood or frequency of a particular hazard occurring, and then also the scale of the impact, the magnitude of the impact. And that essentially enables us to have a good sense of which of these indicators is most applicable to a given location. And that will always be using the geolocation. So this data essentially is specific to a point on the map. And that essentially then enables you to identify, on the one hand, which sites are most relevant, but also which hazards are most relevant for taking forward for further analysis. So just to sort of give you a bit of a kind of overview then of what this sort of phase two asset-specific deep dive might look like. So first of all, you're identifying the relevant hazards for a location. So as we just saw, that would be looking across a range of different indicators and seeing which ones show up as having a higher score. And then essentially looking in more detail across those hazards to calculate a score for each of them individually, and then taking that information to perform a climate risk assessment, where essentially what you're doing is at that point in time not just thinking about the physical hazards, but the interaction of the hazards. So let's say extreme rainfall with the site-specific components. So it might be that that you have, let's say, a loading bay, and it's exposed to extreme precipitation and therefore could be flooded, something like that. So whatever is actually happening at the site. And if you're also taking a double materiality perspective, so not just thinking about the impact on you and your business, but your impact on the wider locale, then you'd also be looking at the impact on nearby receptors in the local area. And then lastly, that's stage 4, so developing a climate adaptation plan. And so as part of that stage, typically what we're doing is engaging with the personnel at a relevant location, whether that might be a site manager, risk manager, or other people working there who may have done parts of this exercise already and can feed into developing, firstly the risk assessment, but then also a good adaptation plan of what you can actually do about it, practically speaking. So that's a sort of overview. Just talk a little bit about where our data is coming from. So you may be aware we have a company called Clim Systems that is part of the SLR family, essentially a team of climate scientists and data scientists based in New Zealand. They've been heavily involved in various pieces of academic literature over the years, and essentially what they're doing is providing multiple different climate metrics for a point location, looking out 2100 across different climate scenarios. And so very useful partners to have on board, both from a data point of view, but also if when we're doing the work, we need some climate scientists in the room to help explain either the metrics themselves or what could happen in a particular scenario. That's also expertise that we bring into these projects. So maybe just talk a little bit about what does best practice look like when it comes to how you define climate risk. So this is from the ISO 14091 standard. And essentially what it's telling us is that if you want to define risk, there's sort of two variations. There's pre-mitigation and post-mitigation, and that's really the way you should do it. And the way to define that risk is to say it should be the hazard times the exposure times the sensitivity. So the hazard is essentially the physical indicator manifesting. So let's say we talk about extreme wind. It could be sea level rise. It's essentially a physical process that doesn't actually become a risk until it interacts with that human system. So the question is, to what extent is your process or your asset or whatever it may be that we're looking at, to what extent is it exposed, which to some extent can be a bit of a binary. It either is exposed or it's not. Sensitivity is the degree to which it is exposed, essentially. To what extent will it be impacted by that particular hazard? So you're combining those to come up with a risk score. And then the other piece of the jigsaw is to then add this other concept of adaptive capacity. So how easy or difficult is it for you and your business or your process to actually adapt to that change? And there's a sliding scale. So some things, for example, are going to cost lots of money and you may never have done them before. There may be other things that are actually very similar to the things you already do. You already have the internal capacity, and actually they don't cost very much money at all. They're relatively straightforward. For example, adapting shift patterns in order to cope with higher temperatures. That's something that should, in theory, not cost too much. Maybe it might cost you a little bit in productivity, but it doesn't involve building a giant seawall, for example, which would obviously be a lot more expensive. So that's how to think about climate change risk. And what we do, essentially, we've built a framework which applies not just to physical risk, but also to transition risks. And essentially what we do here is we combine these concepts of exposure, sensitivity, adaptive capacity to compute a vulnerability score. And then we also look at likelihood and likelihood of impact and also the magnitude of impact, which you're probably quite familiar with from any other risk register you might use. And that essentially computes a score from 1 to 100, and we look at that across different warming scenarios. So it might be like a high, medium, low, and then also different time frames. So depending on typically what the business already does when it thinks about short, medium, and long term. That said, that might also need to be adjusted somewhat, as your typical timeframes might not cover the full spectrum of these climate impacts. So that's broadly speaking our approach. And I guess the key message here is it is aligned with the ISO, IPCC, and all these other frameworks when it comes to thinking about climate change risk. And it's also relatively straightforward, as all of these individual components we score on a 1 to 5 basis, but then aggregate up to give you a score of 1 to 100. So that's how we think about climate change risk. Now let's talk a little bit about the actual sort of specific process. So now this is essentially just sort of taking you through from start to finish how we do a climate change risk assessment, at least conceptually speaking. So the first thing is that we're saying what climate hazards are relevant to your location. And you may remember from the last webinar, there is essentially a set of indicators or hazards that are in the EU taxonomy that need to be covered. So we look at those, but it might be that some are not relevant. So for example, you've got things like glacial lake outburst that isn't necessarily relevant to all sites. So that's the first thing we do. The next thing we do is we screen those hazards, and we have a score, which essentially is a score from 1 to 10. And what we're essentially saying here is which of these hazards is relevant for a given location. So those that are scoring high or medium, we take forward for further analysis to prioritize. Then what we do is, when we're looking at a specific site, we would then scope in or out relevant site components. Then depending on whether or not you're looking at the local area, we'd also think about local receptors. So the components really are trying to break down a site into the different component parts so that we can think about how they might function or indeed degrade or cease to function because of a climate impact. And then what we're doing essentially is scoring these. So here we would have scoring them based on their exposure. As I mentioned before, it's typically binary. They've made it into the list. They usually are exposed. we're then thinking about the sensitivity on a score from 1 to 5. And essentially that's a mixture between using our scoring criteria. So we have a description of what a 5 looks like versus a 1, but then also mixing that with your own pre-existing enterprise risk management framework that might have certain thresholds, for example. So if something is going to be impacted and it's going to have this financial value, that might be a 5, whereas if it's a slightly different financial value, it might be, say, a 4. And essentially that enables us to compute a pre-adaptation risk score for each of the interactions between the hazards and the components. And then we also write impact pathway statements where we're explaining how this risk could interact and adding any justification to the risk score. So that's broadly speaking how we do that. And then what we do is we move on to the adaptation plan piece. And so what we're essentially doing now is engaging with local site staff and others within the business to say, well, how could we go about mitigating those risks? And essentially that enables you to identify an adaptation plan, but it also enables you to develop a score for your adaptive capacity. So in the process of going through those interviews and speaking to people, you can get a better sense of how easy or difficult it is to actually adapt. So once you have that adaptive capacity score, you're then able to add that to the formula to have a risk score that is post-adaptation or post-mitigation. You could also think of it as. So then we move on to the more detailed adaptation plans. And so this is an example of one that was produced for a client. When we decided to work in Excel, we actually found that it's easier for the client to then integrate that into their existing processes, but something we can also produce in Word or PDF or however might be most useful. But essentially breaking down the climate variables, the impact, what control measures there may already be, and then suggested adaptation actions going forward with then who is actually responsible for doing that going forward. So just to say, so within SLR, we have our climate resilience team, part of our ESG strategic advisory, where we're often thinking about climate strategy. We also have experts within process engineering team, civil and structural engineering team, which we often draw on when we're, for example, trying to think about what the potential costs could be of different adaptation options. And then we have our climate data and analytics expertise. So really the idea is to be bringing together cross-disciplinary teams that can serve you best and really help get a better outcome with these projects. So that's one of the advantages of working with SLR on these projects. So a couple of other things just to mention. So we talked a little bit about financial impact quantification. Ultimately, this is sort of where we're trying to help our clients get to, is to sort of say, well, which is ultimately the same as or similar to TCFD scenario analysis, where you might be saying, well, what is the potential financial impact of a particular climate risk manifesting? And it might be that you're thinking about that in terms of ranges from high, medium, low. Maybe the medium is your base case, and if you can then layer that on with climate adaptation measures as well and have a decent sense of how much those might cost, you start to be able to formulate quite a good business case, which can be put to senior decision makers as to whether or not we should be investing in certain adaptation measures. The other thing to say is that within the CSRD, so CSRD then has these ESRS guidance or requirements, there is essentially a requirement to explain your financial exposure to different climate risks. And so that's also something that falls out of this type of activity, where we're using the climate hazard scores and then mapping that to the different assets that you might have to essentially meet that reporting requirement. And really, it's that part of the idea here is to be able to give you a better sense of where those hotspots are, and this is the type of thing that can also be used to determine where you might focus your efforts in doing a deeper dive climate risk assessment. If, for example, you see that you have a particular site that is 50% of your financial value, then it would make sense to do a climate risk assessment deep dive there. Maybe the others don't add up to such a large sum. So just to recap then, essentially what we're talking about in terms of our generally advised process would be either you're screening all of your assets to identify climate hotspots, and then you would prioritize those most at risk to then do a climate risk assessment, or you might already know the most relevant sites for a climate risk deep dive, and that would be your starting point. When it comes to doing a climate change risk assessment, one key thing to keep in mind is that it's really about making sure that the lifespan of the asset is covered within the timeframes that are used. Sensible to go a little bit beyond if there's some doubt, and also there's the idea that you should incorporate different climate warming scenarios. Then the final part of the jigsaw is then thinking about that climate adaptation plan. So essentially, what are you going to do about those main risks? And then if it is useful, another option is to think about a cost-benefit scenario analysis to say which adaptation options actually make the most sense financially for the business and enable us to make good decisions on that front. So that's broadly it for today, but just before I finish, I'll just mention that through CLIM systems, in addition to typically how we work, which is reports for clients that they can then read and review, there is also the possibility for clients that have a lot of sites to actually have a digital platform. There's a Climate Insights web portal. So let's say you've got 50 or 100 sites, then you can actually view all of this in an online dashboard, which essentially generates those reports and provides them to you, and you can sort of navigate around in a slightly more dynamic way. So this is just sort of an example of what this looks like. But yeah, if anyone's interested in this kind of information or needs any help with this, then feel free to get in touch. So yeah, I'll wrap it up there and maybe ask Nicole if there are any questions.
Hi Sam, yeah, we've just had a few questions come through the chat box. So the first one is, could you elaborate on how to prioritize which sites or assets require in-depth climate risk assessments in a multi-site organization?
Yeah, sure. So I think there's really two ways to think about this. One is really looking at where you might have the greatest physical risk exposure. So, as we talked about earlier, the ability to look at all those sites and see where the physical hazards are likely to manifest the most. But then the other way is really thinking about the financial materiality. And typically we would work with a client to define some sort of scoring system. So it might be based on things like revenue, number of employees, or it might start to think about the number of dependencies, so that you could essentially determine which sites within the business are the most critical, and then use that as a determining factor. And then of course the other option would be to combine both of those approaches, but if you were going to do that, then you would need to have screened all your assets. So you're somewhat back to square one, in that you might want to prioritize to some extent. Really depends on, I guess, how many assets you have. Yeah, I hope that answers the question.
Thank you. So I've got another one through. How do you incorporate location-specific climate data into risk assessments, and how important is this for accurate adaptation planning?
Yeah, sure. So yeah, you might have seen sort of various open source climate data sets that often will give you information at, say, the scale of a country or maybe a region. But what we find is that actually there can be quite considerable variation when you look at the results based on specific points on a map. And when I say specific points, I mean I'm talking about 5 kilometers by 5 kilometers, or sometimes even smaller, 1 kilometer by 1 kilometer. So really, it is very important to try to use location-specific data. Typically, what we do is either ask clients to provide us an address, which hopefully they have, or it can be longitude and latitude coordinates on a map. But really, yeah, the point is that wherever possible, it is much better to use location-specific data. Obviously, the challenge is you need that information. So sometimes, yeah, it can be a little bit tricky. Some companies only might have the headquarters of their supplier, which doesn't give a very accurate result. So sometimes it might be a case of trying to at least get closer to the right region rather than just using a headquarter location, which might be completely wrong. Any other questions?
Yeah. So another one we've had through is, what is the significance of scenario analysis in assessing physical climate risks, and how do you choose which scenarios to use?
Yeah, sure. So it's a good question. Well, so the IEMA guidance on climate risk assessments, essentially what it's saying there is you should always use the highest, say the sort of highest warming scenario, which is going to lead to the greatest physical impacts if you're just doing one scenario. Most of the guidance, as I showed earlier, talks about using several scenarios, but I think really the key point would be to always use at least the highest warming scenario available from whatever provider you're using. So whether that's RCP 8.5 or SSP 8.5, and then to some extent there's a bit of a question mark as to what does your business or management team think is sort of useful as well. But generally, what I would suggest, given that sadly temperatures continue to rise, we should be certainly planning for these kind of worst case physical impacts. Also, it's just not that useful to look at a climate scenario that tells you that there's not going to be very many physical impacts. That's not very useful from a planning point of view. So yeah, definitely use higher warming scenarios if you're using any.
Thank you. Another one, how do you ensure that adaptation plans remain flexible and effective given the uncertainties in climate projections?
Yeah, so I think there's a couple of sort of concepts here. One, there's a framework called dynamic adaptive pathways, which is quite a useful one to think about. But ultimately, really, the idea is to develop options that are low regret or no regret in sort of all scenarios. I think that's sort of the main thing to think about. But when we think about dynamic adaptive pathways, the idea really is that you might develop a plan which involves taking certain decisions when certain events trigger or when you get to certain thresholds in the future. So essentially, it enables you to develop a plan that is responsive and is flexible as things evolve. So yeah, I definitely think that part of an adaptation plan is also having a periodic review system built in, as things obviously are changing over time, including the weather.
Thank you. So another one we've had through is, how do you quantify the financial impact of climate risks and adaptation measures for businesses, particularly across different warming scenarios?
Yeah, sure. So I think what we've tried to do with clients where they've had these challenges is actually look to our civil engineering team to be able to develop cost estimates of actually if you're doing certain adaptation measures, how much would they cost? Obviously, you can also work with the business. They might have better data that you can use to sort of inform those models. So that's on the one hand, it's essentially building up a cost model of the different things that you might need to do. And then on the risk side, essentially it's very similar to what we're doing with climate scenario analysis in general, where you're really trying to think about how certain value drivers may change under different scenarios. So, I mean, for example, if you were to have a flood and it was going to take out a particular location, or stop that site from functioning, you might say something like, well, there's this much revenue being generated by the site. We can work out how much revenue is generated per day, and you might be able to make an estimate based on the number of days the site is shut down. Of course, there are challenges with this type of thing. It might be that there's knock-on effects that are perhaps harder to model. Maybe there's brand impact. I think that the challenge in general with climate scenario analysis is that it's not really, or you're not able to get a perfect number. So I think it's really just about building up a sensible set of assumptions, documenting those clearly, and also potentially thinking about having a range of low, medium, high, so that you can get a bit of a spectrum of results that you might have more confidence in the range overall than a specific number. Yeah, I think that answers the question. Are there any more, Nicole? Or?
No, that's all the questions we've got for today.
Okay, well, thanks very much, everybody. Yeah, if you have any other questions, do feel free to get in touch. And yeah, if you need any help with climate change risk assessments, then please do let me know. All right, thank you very much.
Thanks, everyone. Bye.
Okay, bye-bye.